All right, hello, 8th grade. We are working on lesson 4.4. We are going to be comparing linear and non-linear functions. If you have not already done so, make sure you turn in your books to page 170. And we're going to go through this. All right, first off, the graph of a linear function shows a constant rate of change. Okay, a non-linear function does not have a constant rate. So when you're looking at these, if it's a constant rate of change, you'll have a nice straight line in your graph. If it's a non-linear function, a lot of times you'll see stuff like this, or curves, whatever. This means this is a non-linear function. Okay? So, example 1, I've already put it up here on the board. Does the table represent a linear or non-linear function? So they give you the x and y's, input and output, and you can see that each input increases by +3. And at the same time, each output decreases by -8. These are constant, right? These are values that don't change. So would this be considered a linear function or a non-linear function? This one is a linear function. So you would say linear function. And then if it tells you to explain, you're going to say, as x increases by 3, let me type this. As x increases by 3, y decreases by 8. And that's how you would explain how this is working. All right, so now let's look at B. You can see here that the x is very constant. It goes up by 2 each time. But as the y increases, what happens? It changes each time. It's not always going to be +9. So then this function would be considered nonlinear. This is a nonlinear function. And to describe this one, you would say as x increases by, what did it say, 2, y increases by different amounts. Okay, so that's how you would describe what's going on for B. Okay, so this is using a table. Okay, you just find the change each step and decide if it's linear or non-linear. And then explain it to me by telling me what happens with x and y. So let's look at example 2. Okay, again we have an A and a B. So does the graph represent a linear or non-linear function? Okay, the key thing is here is linear means line. So looking at A, is that a straight line? Not at all. So this function would be non-linear. Okay, what about for B? Is that a straight line? Yeah, it's a very straight line going across on -2. So this would be a linear function. All right, so now let's do on your own number 1. Okay, here's numbers 1, 2, and 3. We'll do all 3 of these. Does the table or graph represent a linear or nonlinear function? So when you're looking at the table, you're going to look to see what happens between each step. So you see here 0 to 7 is plus 7, right? 7 to 14 would be another plus 7. 14 to 21 would be another plus 7. So far this looks good. Okay, 25 to 20 is minus 5, right? 20 to 15 is minus 5. And 15 to 10 is minus 5. So you could say that this one is linear, because those are constant rates of change. And then explain it, you would say as x increases by 7, y decreases by 5. Good. All right, so let's look at number 2. All right, this one went up by 2, so plus 2. 4 to 6 is plus 2. 6 to 8 is plus 2. Okay, 8 to 4 is minus 4. 4 to 0 is minus 4. And 0 to negative 4 is minus 4. So this one, again, would be linear, because they change very constant. And you would say as x increases by 2, y decreases by 4. Good. All right, so let's look at number 3. Now, this one can try and trick you because it is a nice straight line here, but then it completely changes directions. So, because it changes directions, this is a nonlinear function. That was easy. Done. Okay, make sure you have those on a separate piece of paper. All right, let's look at example 3. Okay, in example 3, which equation represents a nonlinear function? All right, so we have A, which is y equals 4.7. We have B, which is y equals pi times x. We have C, which is y equals 4 over x. And D, which is y equals 4 times x minus 1. So which equation represents nonlinear? That's what we're looking for, nonlinear. Okay, well, do you remember what the equation of a line is? The equation of a line is y equals mx plus b. So all the equations that look like they're y equals mx plus b would be considered linear. So we just need to find the nonlinear one. So let's look at A. Y equals 4.7. Now it's missing the mx, but can you have a 0 for mx? Yeah. This just means it's a horizontal line right at 4.7, so this would be linear. So let's look at B. Y equals pi x. It doesn't have a plus anything, which could mean it's just plus 0. Pi is just 3.14, so this one is in slope-intercept form, so that would be linear. Let's look at C. C equals 4 over x. Is this in slope-intercept form? No, it has the 4 on top of the x. You'll notice this is indirect. Is that it? Domain function? Direct, indirect. So this one would be considered our nonlinear form. You cannot draw a straight line out of this. And just to double check, if I were to simplify this, I would get 4x minus 4, which is a linear function. So the answer to this example is C. C is our nonlinear equation. All right, let's look at example 4. so this is example 4, and I'm not going to force you to graph it. You can just look at the graph that they have here. All right, account A earns simple interest. Account B earns compound interest. The table shows the balance for 5 years. Graph the data and compare the graphs. Okay, so simple interest is shown by this formula, I equals PRT. If you don't remember how to do this, go watch the lecture I just did for 7th grade, 4.4. Their whole lecture is on simple interest. So it says, in this case, account A earns simple interest. So simple interest is written I equals PRT, and you plug in each part. And you can see that they've already done the balances for you. Account B earns compound interest. You can see that they've done the balances for you there as well. So you need to see what the difference is between each of these. So if you look at account balance A, for both of these, X value is increasing constantly. It goes up by 1 year each time. But for account A, you see it goes up how much each time? Each year they make $10. Okay, that's simple interest. Every year they make $10. In compound interest, you see that it increases by different amounts each time. So this one is obviously nonlinear, because the Y value increases, I can't write today, increases by different amounts. And you can see the graph here. The account B is the red line, where at some point it starts to curve. So this would make it a nonlinear function. They're going to make more money using the compounding interest. What compounding interest does is it gives you interest on the previous balance. So the first time I made $10 because it was $100. The second time it took into account the $110 and gave me the new amount that I made. So each time I have a little bit more money in the bank that it multiplies times the interest. Simple interest just always applies it times your original amount. So you don't make as much money. Okay. That's it. You're just telling me which one's linear and nonlinear, and then I need you to have this statement written in there somewhere. Okay, so that's example 4. Let's do on your own numbers 4 through 6. So on your own number 4, for each of these, does the equation represent linear or nonlinear, and then explain it. So we have y equals x plus 5. So what would you say that? Is this in our y equals mx plus b? Yes. So this function is linear. And then to explain it, you would say, I'm going to type it because it looks better. The equation is in slope-intercept form. All right. So let's do number 5. Number 5, we have y equals 4x over 3. Now, at first glance, this doesn't look like a slope-intercept form. But if I simplify it, I would get y equals, and you can simplify this as 4/3 times x. Now, you could have a plus 0 on the end of this, but you don't have to. So in this case, yes, this one is linear. And you could say it is because it can be written in slope-intercept form. So the equation can be written in slope form. Good. All right, last one. Number 6. We have y equals 1 minus x squared. All right, big giant hint right here. Anytime you see an exponent, this is nonlinear. Okay, because your graph's going to go like this, or like this, or like this. It's just going to be all over the place. Anytime you have an exponent, it does funky curves. So then the explanation on this one would be the equation cannot be written in slope-intercept form. All right, that's it. That's all on your own. Okay, should be able to do this lesson very easily. This is lesson 4.4. Oop, I need my pen. Lesson 4.4. You have already completed now the OYOs numbers 1 through, 6. You need to do the practice and problem solving exercises numbers 3 through 23. Then please take a picture of each page that you do this on and upload it here in Google Classroom.